Hello and welcome to another Rygate Maths video. My name's Simon, and in this video we're going to be looking at one of the really useful tools to prove results, use results, and a tool that's used quite often in A-level exam questions, the discriminant. What we're going to look at is kind of what it is, what its uses are, and then look at a couple of different ways that it appears in exam questions. So this is all to do with quadratic equations, specifically quadratics. This idea of a discriminant really doesn't exist for anything that's non-quadratic or doesn't have a quadratic-like shape. So if we take a look at these three quadratics here, we've got y equals x squared minus 3x plus 2, y equals x squared minus 2x plus 1, and y equals x squared plus x plus 1. Relatively similar polynomials, but you can see from the graphs they all look a little bit different. Now, there are lots of things that do differ between each of these three graphs, but there's sort of one thing in particular. We can see here this graph crosses the x-axis twice. So this has two real roots. This one touches the x-axis exactly once, so it has one real root, and this one doesn't touch the x-axis at all. So this has 0 real roots. Now, just looking at these graphs, you can see that. But if we didn't have the graphs and weren't sure how to draw them particularly easily, what could we use to find that information out? And that's where this idea of the discriminant comes in. So let's have a little look at solving these equations equal 0 to find the roots. And I'm going to do this using the quadratic formula. So if we think about 0 equals x squared minus 3x plus 2, we know that x is minus b plus or minus the square root of b squared minus 4 times a times c all over 2a. So we get 9 minus 8 all over 2. So 3 plus or minus root 1 over 2, which in this case is 3 plus or minus 1 all over 2. So we get that the roots are either 4 over 2 or 2 over 2. Doing the same thing here, if we are solving x squared minus 2x plus 1, we can use the quadratic formula to get minus b plus or minus the square root of b squared minus 4 times a times c over 2a. Tidying up the function a little bit, or the numbers a little bit, we get 4 minus 4 over 2. So we get 2 plus or minus root 0 over 2, which is just one root of 1. Here, if we try and solve this one, we should see that we get minus 1 plus or minus the square root of 1 minus 4 times 1 times 1 all over 2. Minus 1 plus or minus square root of minus 3 over 2. And we know that we cannot square root a minus number in using real numbers. So the big thing that is determining the number of roots is this part here under the square root sign. And that is the discriminant. So the bit under the square root is b squared minus 4ac. We call this the discriminant. And information about this b squared minus 4ac is what is going to tell us not what the roots are, just the number of roots. So this information is about the number of roots or solutions of a quadratic equation. So we saw on this left-hand one that this b squared minus 4ac thing underneath the square root sign was bigger than 0. So that meant we had 2 real roots. In this middle example, this b squared minus 4ac was equal to 0, and we had 1 real root. Now, the issue with this middle case is that technically we have 2 roots, but they're the same number. So you might see this as written as a repeated real root, or equal roots. Something along those lines, to say they're 2 but they're the same. And then in this last case, we had a negative number under the square root sign, so we had no real roots. And this information here is kind of the principle behind this entire topic. So sometimes you might be asked to work out the b squared minus 4ac, find out what the number is, whether it's positive, negative, or 0, and then say, that means there's this many roots. Or you might have to use this information backwards with other topics, typically things like solving a quadratic equation, solving a quadratic inequality. So let's look at a few examples of how this can come up. So this first example, it's unlikely that this is going to be kind of the style of question you get asked, but it's a good way to kind of practice using this discriminant. So, calculate the discriminant and state the number of roots if y equals 2x squared minus 5x minus 7. So we can see here that a is 2, b is minus 5, and c is minus 7. So our discriminant is b squared minus 4ac. So minus 5 squared minus 4 times 2 times minus 7. 25 minus 4 times 14, or 4 times minus 14, so we're going to get plus 4 times 14 is 56, or 8 times 7. Adding them together, we get 81. What the number is kind of irrelevant for what we're finding out. This is a positive number, so therefore we have 2 real roots. And this is kind of the simplest case. It might be framed in this way, or it might be prove that this quadratic has 2 real roots, and you can do it in this way. This comes up in a lot of different contexts if we're looking at any points of intersection question where once we solve simultaneous equations, our function reduces down to a quadratic, we can say that's the same number as the number of points of intersection. So that's a really useful tool, and why this comes up a lot. So this is a kind of very basic example. The next example we're going to look at is a little bit more aligned with what you might have to do in the exam. So this example 2 is a little bit more of a typical exam style question. It can be done in a bunch of different ways, but it's all broadly the same thing. First thing you need to look at is we're told the number of roots. It says equal roots, so it means 1 real root. The fact that we're told something about the number of roots means that we need to use the discriminant. So in a bigger exam paper context, that's a big key thing that you look at to go, right, this is a discriminant question. So we know that we've got equal roots, which tells us that b squared minus 4ac is 0. This is the thing we know. So we know that this is true. So b is k. So k squared minus 4, a is 3, c is 12, equals 0. So k squared minus 144 is 0. And then we have a quadratic equation in k that we can solve. So we can see here, find k. There are 2 values of k. So what this means is that if we put these numbers back into the equation, so if we had 3x squared plus 12x plus 12 equals 0, this equation has one root. Likewise, if we had 3x squared minus 12x plus 12, this equation also has one root. Any other number that we put here would give us either 2 roots or no roots. Where this comes in is often linked in with quadratic inequalities, which is another video, where you're told that it has real roots. You do the same thing, but instead of solving an equation, you're solving an inequality. So there's lots of variation with this type of question, but broadly, it's doing the same thing. So this last example is a little bit of an odd one in that we're given information about a function, or we're trying to prove something about a particular function. Positive is talking about the y coordinate. So what we're saying is we want to prove that for every x value, we get a y value that is bigger than 0. Now, there are 2 ways to do this. The first way is using the discriminant. We'll go through the second way after, which for me personally I think is the way that I would prefer to do. But this example using the discriminant is what students tend to default to. The reason I don't like using the discriminant for this type of question unless I'm told to is in order to justify, you need to do a little bit more. Whereas doing the second method, you need a little less justification. But it's just different. So we're going to use the discriminant. So b squared minus 4ac is. So b is minus 3. So we've got b squared minus 4 times a times c. So we've got 9 minus 20. So minus 11. This is less than 0, which means, as we've seen, there are no real roots. So we've proved there are no real roots, but now we need to justify why that means that y is always positive. Well, if there's no real roots, that means there are no points of intersection with the x-axis, which is great, but that doesn't mean that y is positive, because we could have a graph that looks like this. No points of intersection with the x-axis, there's no real roots, but y is negative in this case. So we need to just look at the x squared term. And since the x squared term is positive, so a is greater than 0, the graph must be above the x-axis. So let's write that in a slightly different way. And since a is greater than 0, the graph must be above the x-axis, therefore x squared minus 3x plus 5 is always positive. The reason I don't like this is this last part here, this written bit, is quite clunky. Now, if we're going to do this question not using the discriminant, which is kind of the more expected way you would do it, is to do with completing the square. So we're going to take this and complete the square, which I'm aware is awkward because we've got an odd number here, but It's fine, we can deal with it. And this is why fractions tend to be more useful than decimals, because 3 over 2 squared, being 9 over 4, is easier than trying to do 1.5 squared. Five is 20 over 4, it's 20 minus 9 is 11. So we've completed the square here. And we still have a little bit of justification to do, but I think the justification for me is a little bit easier. So we can think about that part of our function. Because it's something squared, this must be greater than or equal to 0, because that is by definition, when we're working with real numbers, always true. So that tells us that x minus 3 over 2 squared plus 11 over 4 must be greater than or equal to 11 over 4. We're adding 11 over 4 to the right-hand side, to the left-hand side, we've got to do it to the right. This is why, and if something is bigger than 11 over 4, well, it's definitely bigger than 0. So it's a slightly quicker way of doing it, but a little bit less obvious. Either way's fine, unless you're told a specific method to use, like we are in this example. So for this example, what I've written in red is what you must do. But if it was just show that y equals x squared minus 3x plus 5 is always positive, you could do either method quite freely. But that's the discriminant. Thank you very much for watching.